Hello everyone. Today we will discuss about the linear search algorithm, right? So let's see the linear search implementation. So first what we will do, so basically the linear search function takes an array of target. So here it will take array and the target. So we'll be having array of values and it will consider the target value from the array, right? So as the input, so it searches for the target in the array using the linear search approach. We will be searching the target in the array using the linear search approach. So let's see how can we implement this one in the code. So I'll just delete this one. Let's start writing the code so that you'll get to know this one better. Also, let's see the example along with finally we will discuss about the time complexity and the space complexity. So I'll just come here. Let me give function linear search of. So as we have discussed, it will be array and target. So we will start the loop that will go through each index of the array. So it will be simple. So yeah, this has to be, we have considered array, right? So this has to be length of the array. So within this one, if we find the target at the particular index, nothing but iterated value of the array, if it is equal to target, then what we will do, we will return its index. So here we are checking if the current element in the array matches the target value. In this step, if a match is found, then we will return the current index in the element, nothing but this one, return I, right? Finally, what we will do, if the loop completes and if no match is found, then we will be returning -1 to indicate that it is a failure. So I can write in this line, return -1. Nothing but here we are returning -1 if the target is not found in the array. So let's consider the example here. I'll just take the random array. So here it will be 14, 35, 62, 17, 18. So what shall I give here? Target equals, let me give 17 here. So then we will call the linear search function and store the result in the index. So here I'll just give in this way. Const index equals, we'll make use of the linear search function. We have the parameter array and target, right? So this is one thing. Let's output the original array to the console, and also let's output the result of the search showing where the target was found. So we can just console log in this way, right? I'll just log. This will be the original array. Let's give array. Also here, let me give console log of. I can write in this way. I'll just go with the string interpolation. Target here. This one. We have the target, right? Target 17 we have given. Let's found in particular index. So this will be here. Again, let me make use of the backticks here. And I'll just give index. So we have to display the index, right? So here, I hope this is clear. So let me run this. Let's see. So here what happened? Missing this one. Oh yeah, here. Sorry. Just remove this one. Yeah, let me run this one again. Yeah, here you can clearly see we have 17 in the this one, index 3. So found in, let me give here index. So let me run this one again. Yeah, here you can clearly see 0, 1, 2, 3. Third index we are having 17, right? So target 17 found in index 3. So this works absolutely correct. So if I give here, suppose 99, this has to give us -1, right? So target 99 found in -1. So -1, nothing but we are displaying -1 because if the element is not found in the array, we'll be displaying the -1, saying that it is a failure. So no element is present in the particular array, right? So this is what this code works absolutely correct. So what will be the time complexity and the space complexity? The time complexity is will be big of n. Why it is big of n? Because in the worst case, we may need to check every element in the array, right? So in the worst case, we may have to check every element in the array. So the time complexity would be big of n, and the space complexity is big of 1. Why? Because we are only considering a constant amount of extra space regardless of the input size. So it will be big of 1. So let me come here. The time complexity would be big of n as we have discussed, and the space complexity would be big of 1. So yeah, I hope this is clear. Next, let's discuss about the binary search. This is it for now. Thanks for watching, guys.